Good evening.
Good evening.
So these are the members of group 5. We are now on a model report. So what we were supposed to tackle was supposed to tackle perform separation techniques, and in separation techniques there are those machines that are supposed to be used when you are performing separation techniques. So before that, so when you are performing a separation technique, there are those techniques that are supposed to. So there are what are called one chromatic technique, and then the second one is non-chromatic techniques. So when we talk about chromatic techniques, there are those there are separation in code using stationary phases. So the stationary phases and mobile phases. So for example, those that uses stationary phases and mobile phases, they are GLC, gas liquid chromatograph, and then there are also HPLC, that is high performance liquid chromatography, and then there is TLC, which is thin layer chromatography. So most of these chromatic components techniques, they don't use what? They only use stationary phases and mobile phases. And then for non-chromatic techniques, so these are, they do not rely on phase interactions. So those phase interactions include filtrations, distillation, and centrifugation. Okay? So when we talk about this on chromatics are easy kind of filtration, distillation, but non-chromatic phenomenon use filtration, those phases. Okay? So and then the second one, there is components of the chromatic instrument. So now we are discussing the chromatic instrument. So the chromatic instruments. So when you are using chromatic instruments, so the first one, there is what is called sample introduction system. Sample introduction system. Sample introduction system. So introduces small volumes of prepared samples. So for here, when you are doing for this chromatic, so we introduce small samples into the sample production system. So examples, one of them that you can introduce, syringes for manual use, auto samplers or automated eye-through analysis, splitters injectors for gas chromatography. Okay, and then the second one is called mobile phase delivery system. Mobile phase delivery system. So mobile phase, what happens in the mobile phase? So transport the samples through the stationary forces at a controlled flow rate and pressure. So that is the function of a mobile phase. So it transports the samples through the stationary phase at a controlled flow rate and pressure. So examples are HPLC, which is include high pressure, and then also there is GLC, carrier glass cylinders with flow controllers, helium, hydrogen, mobile phase. And then the third one is column. So in column, the post-separation units where components of the samples interact. So components of the samples interact differently with the stationary phase, leading to the separation based on properties like polarity, their sizes, or volatility. So types, so there are two types of columns. There is what is called packed column, which supports the solid coated with stationary phase, or capillary columns for higher resolution gas chromatography. And then also another type of column is called a reverse phase or a normal phase columns, which is used for liquid chromatography. And then number 4 is detector. So detector detects separated compounds as they elute from the columns and converts their presence quantity into measurable electrical signals. So we want to go into the types of those detectors because there are many, because each component uses. And then the last one is data. The last one is data acquisition and processing system. Once you've detected, so now you process the data and processing unit. So records, displays, analyzes, and detects signal to generate chromatography. And also it quantifies the results. To quantify this means it shows the heights of the concerned calculations. So let me welcome my colleague to continue with the third one.
Okay, good afternoon. I present you the detection system in chromatography. Detection system in chromatography. And I think we are going to discuss the types of detectors. And once we have optical detector, and this entails of UV detector and fluorescent. Detector. Two, we have electrochemical detectors. And 3, we have the mass detectors, mass spectrometry. And the optical detectors, it explains that UV, it entails of UV visible detectors which explain its principles as measures absorptions of UV light by analyzing chromophores. The next one is fluorescent detectors, which is under the optical detector, which its principle is that if the excites analyzed with specific wavelength are measured, then measures the emitted fluorescent at a longer wavelength. First, it measures with the shortest wavelength, then followed by the one with the longer wavelength. Another type of detector is electrochemical detectors. This measures the electrical signals generated by the analytes undergoing redox titration. The number 3 is mass spectrometric detectors. Mass spectrometric detectors, its principle is that it measures the ionized analytes and separates them by mass to charge ratios, providing both qualitative and qualitative analysis. And that makes the end of types of detectors.
After that, we are going to check on separation using GLC, HPLC, PLC, and data chromatography. So, under PLC, we have the PLC mostly deals with separation of components based on absorption and solubility in liquid motile phases. And then when we check on HPLC, HPLC deals with it uses high pressure pumps to deliver a liquid motile phase through a column packed with a small particle stationary phase. And then we have also the GLC. TLC, it separates volatile compounds based on their partition between gaseous mobile phases and a liquid stationary phase coated on a solid support in a column. And then we have the applications. We have applications of TLC and HPLC. For TLC, analyzing fuels, environmental pollutants, volatile organic compounds, and drugs in biological fluids, testing food and beverage quality. And then for HPLC, quantitative analysis of pharmaceuticals, food additives, environmental pollutants, and biological samples. And that marks the end of our